they gave you the following data, right? They say reaction X and reaction Y and reaction Z, which is the correct order of pH values of the above reaction mixture. Okay, so I'm just gonna run through how you do the get a pH of reaction mixture X. So you have this amount of acid and you added 25 cm³ of water. So in fact, I would say this, the volume doubled. Okay, the volume doubled, which means the concentration actually halved. Okay, so the concentration of CH3COOH is actually now 1 times 10 to the power minus 5 moles per dm cube. Okay, so this is a weak acid, so there's a formula to calculate the pH of weak acid. H plus equals to square root Ka times C. Okay, what is Ka? Ka is given to be 1.8 times 10 to the power minus 5, all right, multiplied by the concentration acid, which is actually 10 to the power minus 5. Okay, work it out. Okay, so you can find out H plus, and then after that you can find out pH. All right. Okay, and in this question I've already done the calculation. The pH is actually 4.87. Okay, let's look at reaction 2. So 25 cm³ of this amount of acid reacted with so much base. So the number moles of acid that we have here, let me calculate. Okay, the number moles of ethanoic acid here will be 0.0005 moles. Sodium hydroxide will be 0.00025, right? So I'm just going to do ICF. So this is a change, all right? So you can see that ethanoic acid is limiting. So it's actually, sorry, you can see that in fact the sodium hydroxide is the one that's limiting, right? So calculate is 0.00025, yeah, 0.00025. Okay, if you look at the final line here, okay, you notice that the weak acid and the conjugate base are of equal amount, right? So which means they will have the same concentration. So this is what I call the maximum buffer, all right? This is what I call the maximum buffer. So for maximum buffer, we're going to apply the formula pH equals to pKa, right? So pK is minus log Ka, which is 1.8 times 10 to the power minus 5. So this gives you a value of 4.74. Okay, let's look at the last one. So I have so much acid and so much base. So let's do the calculation again. So the number moles acid is 0.00025. Okay, the number moles of base in fact is 0.0005. So in this case, if I do ICF, in fact now ethanoic acid is the limiting one. Okay, so at the end of the day, what's on the final line? You have 0.00025 over here. This is 0.00025. Okay, so at the last line here, you notice for reaction Z, you have sodium hydroxide and the ethanoic ion. Okay, by looking at the number moles of sodium hydroxide and ethanoate, it shows that this solution is highly basic because it's essentially a lot of sodium hydroxide. Okay, so which means they will have the highest pH. So let's do the ranking now. Okay, let's do ranking. So the one with the highest pH, all right, the one with the highest pH would be Z, all right, and the one with the lowest pH, let me check, has to be Y. Okay, so this is the highest, so of course X is in the middle. Okay, so that makes the answer gonna be B.